Good afternoon. I'm Swastiastu. First of all, let me introduce myself. So my name is Wayan Kavindha Ardanareswari from class A with my last digit number is 068. Before that, I will do some share screen here. So today I will do some presentation about my topic is infinite sequences and series, especially about arithmetic sequence. So I will tell you guys the definition about arithmetic sequence by tell you about some keywords. So first keyword is definite pattern. So an arithmetic sequence is a list of numbers with a definite pattern. And the second keyword is about constant. If you take any number in the sequence and then subtract it by the previous one, and the result is always the same or constant, then it is an arithmetic sequence. And the last keyword is common difference. So the constant difference in all pairs consecutive or successive numbers in a sequence is called the common difference, or denoted by the letter D. We use the common difference to go from one term to another. And the next slide. So we got the table here. I will use some annotate. Okay. First, we'll look about the first column. With the first term is 3. And for the term rule is add 6. And for the first 5 terms, we got 3, 9, 15, 21, and 27. So where we got these 5 terms? First, we'll look about the first term. The first term is 3. And the term rule, or we call it common difference, is add 6. So 3 add 6, we got 9. And from 9, we add 6, we got 15. And from 15, we add 6, we got 21. And 21, we add 6, we got 27. So by that, we get for the first 5 terms is 3, 9, 15, 21, and 27. So do with the first term is 8, and for the term rule is subtract 2. So for the first 5 term, we get 8, subtract 2 is equal to 6, and 6 subtract 2 is 4. 4 subtract 2 is 2, and 2 subtract 2 is 0. So for the first 5 term, for the second column is 8, 6, 4, 2, and 0. And for the third column, we got the first term is 12. And the term rule are, this is we can call the common difference. Common difference. Or we can denote it by D, the letter D. So the letter D, for the common difference about the third column is at 7. So for the first 5 terms, we got the first term is 12. 12, we add 7, we got 19. From 19, we got add 7, we got 26. 26, we add 7, we got 33. And 33, we add 7, we got 40. And so it goes on. Because this is just for the first 5 terms, so we just assert the 5 terms. And for the fourth column, we got the first term is negative 4. And the common difference or the term-to-term rule is subtract 5 here. So for the first 5 terms, it's negative 4. We subtract 5, we get negative 9. From negative 9, we subtract 5, we get negative 14. From negative 14, we get subtract 5 is equal to negative 19, and so goes on until negative 24. And for the last column, we get the first term is half, and the term second row is at half, also at half. So for the first five term is we got half, one half, two, and two half. So this is like the pattern. We see the pattern here, and this was searched by the pattern. But we have the formula too, because if we have the pattern, it's not efficient if the number is bigger. So we use the formula. So for instance, the nth term of the arithmetic sequence a sub 1, a sub 2, a sub 3 is given by a sub n. A sub n is equal to a sub 1 plus n minus 1 times d. So this a sub n is time from the nth term, or the term that we find for, and for the a sub 1 is 10 for the first term, right here, and for d is a common difference. Or we can find the common difference with subtract the first term from the next term, or a sub 2 minus a sub 1. So here is the example about the, here is the example about the arithmetic sequence. So calculate the sixth term for the sequence 4, 7, 10, 13, and 16. First of all, we find the common difference first. As I said before, for such the common difference, we use the a sub 2 minus a sub 1. From the sequence, we got a sub 2 is 7, and the a sub 1 is 4. So 7 minus 4 is 3. So for the common difference from the sequence, we got 3 here. And the formula is a sub n is equal to a sub 1 plus n minus 1 times d. So here is, we got the a sub 1, or the first term is 4. N is the term that we find for is 6. And d is common difference. We searched it before, we got 3. So a sub n is equal to 4 plus 6 minus 1 times d, or 4 plus 5 times 3 is equal to 4 plus 15 is equal to 19. So for the sixth term, for the sequence 4, 7, 10, 13, 16 is 19. Okay, so there is another formula to find the nth term, which is called the recursive formula of an arithmetic sequence. And it used to find a term of the sequence when its previous term, the a sub n minus 1 and d are known. So the formula is a sub n is equal to a sub n minus 1 plus d. So for example, we get the problem is find a sub 21 of an arithmetic sequence if a sub 19 is equal to negative 72 and d, or the common difference, is 7. So for the solution, by using the recursive formula, we can't search for straight for the a sub 21, but we should search the a sub 20 before. So the previous term. So a sub 20 is a sub 19, or this one is a m minus 1. So n is the term that we search is 20. 20 minus 1 is 19. So a sub 19 plus b is equal to negative 72 as n is known, and 7, d is 7, is equal to negative 65. Because we know the a sub 20, then we search for a sub 21. So for a sub 21, it's same like this, like a sub n minus 1. So n is 21, so 21 minus 1 is 20. So a sub 20 plus b is negative 65 that we searched before, plus 7 is the common difference, and it knows. So negative 65 plus 7 is equal to negative 58. Therefore, the a sub 21 of arithmetic sequence is negative 58. So this is when we use the recursive formula. And the recursive formula is used when we know the previous term and the common difference. So that's all about my presentation. I hope that you understand, and thank you for your attention. Bye-bye.